So I'm a middle school computer science and CTE teacher. And when the world shut down back in March and we all went home and we were trying to figure out what we were going to do to engage our students, someone mentioned this particular resource that Vex Robotics had placed out online. And robotics has always been an important part of my curriculum that I teach with kids. When I work with students on engineering design, when I work with students on programming things like, and programming algorithmic things like conditionals and if-thens and all of those loops and things, I always have utilized the robotics piece. And a big piece of that is because we know kids like robots. It's something that gives them a hands-on and takes some of the intangible, some of the abstract concepts and makes them much more concrete for students. But I've worked with numerous different types of robots in my classroom with my students. But once I got sent home, it was about where we were in the curriculum, and it was, well, we can't do this. I can't send my robots home with the students. They terrorize them enough in the classroom. But we have, so someone mentioned this particular initiative that Vex Robotics had put out. And it was designed to be a virtual robotic system. So students and teachers could utilize the program to do many of the same things that I was doing in my classroom, but they wouldn't have to actually have a physical robot, but it would still allow them to see and interact with a robot on the screen. And there really hadn't been anything much out there that had quite as much flexibility. So I spent some time with it, spent a lot of time with it. Probably was the mistake of our person who mentioned it to give us a link at the beginning of like a curriculum meeting, because I tuned out and just played with the robot. So we played with it a while. And so I worked on developing some resources that we've been using, we use in our county. A lot of teachers have used in our county. And I'm just here to share them with you. So there's not a lot of deep like pedagogy or theory. It's just some very practical types of resources and things for you. So let me tell you a little bit more about what Vex Virtual Robotics looks like, kind of how it works, and then I'll share with you some resources that I developed. So Vex has a robot. This is what it would look like in real life, but this is kind of the capabilities of the robot that they have developed. So the Vex robot has a lot of built-in things, which is really easy to do if you don't actually have to build it. So it has an electromagnet. It has two visual sensors, one that points down and catches the bottom of the screen, bottom of the land, and then one's a front eye sensor. It also senses distance. It has got a gyro location sensor. It's got bumper sensors on the right and the left, and it's got drawing capabilities. It's 4 different colors. So it has a lot of opportunity to do a lot of creative things with it. And Vex has done a really nice job in balancing out some of your challenges and activities between purely more technical type skills to artistic type skills to very practical things, which I'll show you. So this is kind of like a visual to kind of understand how that robot, what it actually looks like. So the way it works is that it is a, you log into this. So let me pop out of here and let me pop over to Vex. So this is the Vex VR Virtual Robotics platform. So it has in it a tremendous amount of opportunity for you as a teacher. So it has built-in tutorials here. So if you pop in there, it has different pieces to use to start with students and to start for yourself as well. They've added a few more teacher tutorials down at the bottom, but there's a ton of tutorials to get students started and to help them with things that are there. Vex also programs primarily, and it's similar to a Scratch-based language for block tutoring, but for students who are more advanced or students who are working in Python or students who may be working in other types of applications, you can also open a text-based product. And the text-based product is available in drag and drop text for, but in Python language, a text-based language. So you have some opportunities there for students. Let me just open this back up. There are built-in activities that Vex has created to be able to give some drills and challenges to students. So let me show you a little bit about how I utilized some of these things. But the best part, actually, let me show you this one first. The best part of Vex, in my opinion, is the playground. So if I open up a quick example, let's just take this one. And I want to see what it looks like. Vex has this virtual playground, and here's where the robot lives. The VR robot lives here on the playground. It has lots and lots of different options. You can see him down here in the corner here. And when you run the program, it's going to show you exactly what it does. So it's fabulous way for students to work on iteration. They run the first part of their program, they see what's happening, they make changes to be able to solve whatever the problem is that they're looking to solve. So the robot will do everything that it's told to do. Usually it'll do those. It's not today. It did a few minutes ago. So no idea. We'll come back to the robot. We'll give them a little break. But there's lots of opportunities here. There are different backgrounds. I think everything's just running a little slow. Things like castle crashers, where kids have to knock down pieces and knock them off of the, of the playground board, which had really slow internet, I think is the concern. So we'll come back to him, but we will take a look here. So let me show you a couple of other things. There we go.
So the question is it a modern day Pac-Man?
You can make it that way. This was just for moving different blocks back and forth, but it has so many other options. It requires, the coding from the students to do anything that's doing, but there's a lot of options. Let me show you some of the things that it can do. So there are resources that are here, and I linked all of them here into the presentation for you, since I won't be able to go through each of them individually. I also did a longer presentation on this for Maryland Center for Computing Education, and I believe that video is in their archives as well. But I just linked some information here. There are multiple languages that are supported within this, so it's a nice support for students who may be learning second language. It gives them the opportunity to kind of work on some of those algorithmic concepts in their primary language, if that's the primary goal that you have for them. There are also resources available for students as they're programming and as they're iterating their design, so that they can look at their program step by step. They can run one step at a time and be able to look at what's happening. A lot of times my students would start the program, they'd write a lot, and then they would get to the end and it wouldn't work, and then they would just be so frustrated. This lets them back up, and many times as you tell them, just write a little piece, see how it works, and then add on. They inevitably write a longer chunk than they need to. So this would allow them to work step by step and process through those things. So there's just a lot of ways to get some help, to be able to look at monitors for things when you're running counters, things like that. But what I did was take the resources that were there at Vex and put them together into a unit that I worked with my students. It was several weeks of unit that we worked on, and it covered these basic concepts. So let me show you really quickly. What's my time? Just want to make sure I don't go over. Do you know?
You have about 5 minutes. Perfect. 5 or 6 minutes.
Okay, so in the unit, there's at the beginning some the tutorial videos that are embedded here for students to be able to see how to get started, how to use the playground, how to load and save, and use help to be able to do the basics. And then students learn about simple robotic concepts like moving and turning. A couple of quick videos here. We worked on it together as a group, and then there are challenges that are available to students. So as students go here and they look at these particular challenges, they link in and find something specific to what those particular skills that they just worked on. So there's multiple levels of challenges. This allows for sometimes differentiation. Some of my students only ever did level 1 challenges. Some of my students only ever did level 2 or 3 challenges, depending on their backgrounds, the speed in which they were learning. But it gives them something very specific that they have to try to accomplish. For example, this one, they just want kids to be able to get the robot to drive forward, turn around, and come back. So some very basic beginning programs, but everything is based around this problem solving, kind of real world embedded type of strategies. So students have an opportunity to share that information with you. Word of warning, I would make sure that they're going to get screenshots from students to turn them in. Make sure they screenshot their entire screen. I had some students who realized that there were some teachers on YouTube who had been showing students how to do some of these as kind of their virtual instruction. And so they were just taking some screenshots of the YouTube videos. But as students move on, they will learn some of the more advanced programming concepts like the magnet features. They have other challenges like being able to move the magnets, move the discs back and forth on the screen to be able to find those. We move into loops, and students have to be able to, on a grid that shows all of the numbers, They have to be able to cross different combinations of numbers, their birthdays. Can they get the robot to the right location? Can they get it to change its markings so that it drops the pen, uses the pen, lifts the pen back up, based on those kinds of loop concepts. My favorite part of the unit, though, is really the ending piece. Once students go through some of the basic conceptual ideas, it's a series of challenges for students. For my students, I put this into a Tic Tac Toe board. They had to start with one, and then they had to choose some way to get Tic Tac Toe. Any of the Tic Tac Toe activities gave them a more technical challenge and a more artistic challenge to look at. And I marked ones that were a bit more difficult. And some of my students who liked a good challenge would choose those. So students worked through some of these basic challenges, and then we moved into the real world opportunities. So these were some things that weren't necessarily in Vex that we added in. One is a fencing option for a farmer who needs to be able to develop a certain sized fence for some chickens, for his chicken Betty. And so students had to look at different ways to get the robot to draw the outside, the perimeter of the fence in different kinds of configurations. So it required them to look and find ways to do that. There is a robotic vacuum, kind of a Roomba programming challenge. So they have a section of flooring. They have to be able to get the robot to cover all of these types of things. So they have to use random numbers. They have to be able to use the sensors to be able to move around furniture and things. So it gives them an opportunity to take those skills and apply them into a real world situation. And the last one is a snowplow challenge, which is working with one of the playgrounds that has a random generation of where the objects are going to locate. So it's not a planned location. So for example, the objects could come up here, they could come up here. You just don't know from time to time when it pops up. So we tell them, since every snowfall is different, the piles of snow are never in the same place twice. So they have to figure out a way to, again, use some of the sensors, use some of the random numbers to be able to clear off the snow no matter where it is. The board has the red line around the outside. They have to use the sensor so they don't fall off the edge of the, get stuck in the snow. So what I really love about the program is that it gives kids an opportunity to work with robotics, even while we're in our county's still in a virtual schooling situation. If we move to a hybrid situation, it still gives students the opportunities that they would have had and gives them a lot more practical application of the robotics concepts and of the computer science concepts that I'm trying to teach them. So it's been a really wonderful resource. The kids really found it engaging. I had some parents complain that it was, kids are spending too much time playing with the robots and not enough time like doing their language arts and science homework, which I personally didn't see a problem in. Just kidding. But it does provide for students to have lots of hands-on opportunities virtually, kind of in the situation that we're in, or even going forward once we're all back in school and everything's back to normal. Buying robots are expensive, and sometimes the funding is just not there to buy or to replace or to add to. So it gives another option for you as teachers to be able to incorporate robotics within your curriculum. So there are some other resources that I linked here for you. There are some things that Vex has available: teacher portals, knowledge bases, pacing and standards alignment guide. I also put some alignment documents into the folder to look at Maryland standards, and just some really nice, they really packaged this well for teachers, and there's no cost. It's entirely free. So I just wanted to share with you what's worked well for my students and hope that maybe it would be a good resource that you could share with your students.